6 machines. That's all that's left after every trend, every gimmick, and every plastic promise of the last decade gave way. Not 6 categories, not 6 brands. 6 machines that are still built to last. And by the end of this, you'll know exactly which ones deserve a place in your kitchen. This video is brought to you by the Durability Project, where we explore why the things we buy no longer last and the engineering decisions that quietly shape their lifespan. Number 1. Air fryer. Most air fryers are plastic shells wrapped around a heating coil. The ones that last are built like compact ovens, metal chambers, balanced fans, and heating elements designed for continuous duty. But buried inside that category is a different animal entirely. A machine with a die-cast aluminum chamber, a brushless motor, and a heating element that is not a thin coil of resistance wire, but a sheathed, high-density element rated for sustained output cycle after cycle. The fan is not a wobbling plastic impeller. It is a balanced, metal-hubbed rotor moving air in a turbulent pattern precise enough to strip moisture from food at a controlled rate. At its heart, a properly engineered air fryer is a compact convection engine. Brands like Breville and Bosch have moved toward these specs, and Yale Appliances service data backs it up. The machines that show up in repair queues least are the ones built with commercial-grade internals inside consumer exteriors. That consistency does not happen by accident. It is the result of tolerances that cheap manufacturing simply cannot hold. Number 2. Induction cooktop. Beneath the smooth ceramic surface of a properly engineered induction cooktop sits a copper coil wound to tolerances measured in fractions of a millimeter. When current passes through it, it generates an alternating magnetic field that induces eddy currents directly inside the iron molecules of your cookware. The pan becomes the heating element. The surface stays cool enough to touch. Induction has existed in commercial kitchens since the 1970s, so this is not new science. But the consumer market spent decades selling underpowered, poorly shielded versions that flickered under load and burned out their inverter boards within 3 years. The machines worth buying in 2026 finally brought the commercial spec home. A full power induction zone on a Bosch Benchmark or Signature Kitchen Suite unit delivers 3,700 watts of responsive heat, more output than most residential gas burners. The inverter board driving that output is the machine's spine, and in premium builds, it is over-engineered for the load, with thermal protection circuits that prevent the cascade failures that kill cheaper units. Bosch's Benchmark line sits at a 7.8% first-year service rate across thousands of tracked units. No open flame, no gas valve, no grate. Just a single ceramic glass panel rated for impact loads that would shatter a lesser surface, sitting quietly above a coil doing the work of a furnace. Now take that same idea and scale it up to something that never turns off. Number 3. Smart refrigerator. 130,000 hours. That is how long a refrigerator runs over a 15-year lifespan. Compressor cycling, fans turning, temperature sensors reading every single day without pause. No other machine in the home asks that much of its components. So when a manufacturer decides to bolt on a touchscreen, a Wi-Fi module, and an internal camera system, the question is not whether those features are useful. The question is whether they compromise the mechanical foundation underneath. A refrigerator doesn't fail because it runs. It fails because something extra was added to a system that never stops running. French door refrigerators are the most service-prone configuration in the entire appliance category. Ice makers, dual evaporator systems, through-the-door dispensers. Each one adds a failure point to a machine that already runs harder than anything else in the kitchen. The ones that survive this tension are built so the intelligence sits above the mechanics, not inside them. GE profiles smart features, cameras, inventory tracking, remote temperature adjustment, run on top of a compressor system validated completely independent of the software. The Wi-Fi module can fail. The refrigerator keeps running. LG Studio follows the same pattern, layering connected features onto a linear compressor platform refined over more than a decade. Number 4. Dishwasher. Inside a running dishwasher, the water climbs to 140 degrees Fahrenheit. The wash arms spin under real pressure. The detergent chemistry runs at a pH level that would strip the finish off lesser materials. This happens 45 minutes at a time, sometimes twice a day, for a decade or more. It is not a gentle machine. It is a contained industrial process. But the real secret lies in what you cannot see from the outside. Two dishwashers can look identical: stainless tub, adjustable racks, 3 wash arms, and be separated by a chasm of engineering quality. The pump motor in a budget unit is a synchronous motor running on a plastic impeller. The pump motor in a Miele or Bosch is a brushless DC motor with a ceramic impeller shaft, rated for a service life that exceeds the warranty by a factor of 3 or 4. Miele builds their machines in Germany to a specification that treats every cycle as an industrial event. Their door hinge has been tested for over 20,000 open and closed cycles. Bosch follows the same philosophy at a lower price point, and you feel it the moment you close the door. Heat is one problem. Pressure is another. Number 5. Multi-cooker. Every pressure cooker works perfectly until the seal doesn't, and when it doesn't, the machine is done. At its heart, a multi-cooker is a sealed pressure vessel, a heating element, a pressure relief valve, and a microprocessor holding everything in check. The engineering challenge is not making it cook well. It is making it hold pressure safely after 10,000 cycles without the gasket flattening or the float valve sticking. What actually determines lifespan is in the materials. The sealing ring and the steam release valve are in direct contact with pressurized high-temperature steam on every single cycle. In budget units, the silicone ring compresses under that load and never fully recovers. It flattens, the seal fails, and the machine either loses pressure mid-cycle or locks out entirely. Premium units from Instant Pot's Pro Series and Breville's Fast Slow Pro use higher durometer silicone, rated above 250 degrees Fahrenheit, a stainless steel float valve, and a thick-gauge inner pot with an impact-bonded base that prevents the hot spots that stress the heating element. The multi-cooker worth owning is the one whose pressure release valve you can disassemble, clean, and reassemble in under 2 minutes, because the manufacturer built it to be serviced, not discarded. If pressure tests seals, speed destroys bearings. Number 6. High-performance blender. Between 25,000 and 37,000 revolutions per minute, blade tips moving close to 200 miles per hour inside a sealed container, grinding ice and fibrous vegetables and seeds hard enough to chip lesser steel. The engineering problem is not the power, it is surviving that power without destroying itself from the inside out. The difference comes down to one component, the radial ball bearing at the base of the blade assembly. In a budget blender, that bearing is sealed, unreplaceable, and when it fails, the machine is done. In a Vitamix, it is a serviceable part. The company will replace it. The machine was designed from the ground up with that reality in mind. The motor driving all of this is a 2.0 horsepower AC induction motor. No brushes to wear, no commutator to arc. It spins on magnetic induction rather than physical contact, so it runs cooler and lasts longer than any brushed alternative at the same price. Vitamix's commercial line runs in professional kitchens at multiple cycles per hour, year after year. The consumer machine inherits that same motor, that same bearing, that same bones. 6 machines, an air fryer built on commercial convection bones, an induction cooktop running a copper coil to laboratory tolerances, a refrigerator whose intelligence sits above its mechanics, not inside them, a dishwasher whose pump motor you will never hear, a multi-cooker whose pressure seal is designed to be replaced rather than to fail, a blender whose motor has no brushes to wear. What connects them is not price, not brand. It is the decision to engineer for the second decade, not just the first 2 years. Check the service network in your region before you buy. A machine with a low service rate means nothing if no qualified technician within 100 miles has ever opened one. parts availability, serviceability, mechanical integrity. These are the real specs. These 6 are still standing because somewhere in their design, an engineer made a different decision. Not how cheap it could be, not how fast it could sell, but how long it could survive. And in a market built around replacement, that decision is the rarest feature of all. Brought to you by the Durability Project.